Hello students, in this video we'll look into some of the CBSE questions which were asked on Pythagoras theorem. So let's begin with the question number 1. In this question, triangle ABC, in a triangle ABC, AD is perpendicular to BC and we have to prove this. AB square plus CD square is equal to AC square plus BD square. So the only thing which we are given is AD is perpendicular to BC. So let's apply the Pythagoras theorem. In the right angle triangle, we have two right angle triangle. So in the right angle triangle ADB, what we can write, AB square is equal to AD square plus BD square. And again in triangle ADC, right angle triangle ADC, we have AC square is equal to AD square plus CD square. So if you look in the final result, this is the final result, we don't have AD in the final result. So let's eliminate the AD term. So substituting AD, let this be 1 and let this be 2. From here we can get AD square is equal to AB square minus BD square. So let's put this value in the equation 2. So AC square is equal to AD, instead of AD we'll substitute the value of AD. Why? Because we don't want AD in our final result. So let's do it. AC square is equal to AD. Instead of AD I'm going to write AB square minus BD square. Then we have plus CD square. So let's bring the minus term here. So we'll have AC square plus BD square is equal to AB square plus CD square. Hence our final result is proved. AC plus BD square is equal to AB and CD square. Hence proved. Now let's take another example. In this example, triangle ABC is given, in which angle A is 90 degree and AD is perpendicular to BC. We have to prove that AD square is equal to BD into CD. So let's prove some triangles which are similar. Which triangles will be similar? This is smaller triangle, triangle BAD will be similar to triangle B. We have B is the common. Then instead of D we have A. So this is BCA. Okay, I'm going to show which triangles. Triangle BAD, this is the smaller triangle, and the bigger triangle, triangle BCA. Yeah, in these two triangles we have angle B equal to angle B, both are common. Angle D equal to angle A. Why? Angle D equal to angle A, both equal to 90 degree. So by AA similarity, these two triangles are similar. By AA similarity, okay. Now again we'll take another triangle. This is a smaller triangle, triangle ACD, and again the bigger triangle. So let the bigger triangle be BCA only, and the smaller triangle, how we're going to write it? Angle BC, and here angle C is common, so C, and instead of A we have D. For A we have D, and then we are left with what we are left with? We are left with, in the smaller triangle, A. So ACD is similar to triangle BCA. Again, why? Because angle C equal to angle C, both common. Angle D is equal to angle A. Yeah. So by AA similarity, these two triangles are similar. Hence, we can also say, as both these triangles are similar to triangle BCA, therefore we can write these two triangles are also similar. That is, triangle BAD is similar to triangle ACD. So, as they are similar, we can say their sides are proportional. So which sides I'm going to take? Obviously, which involves AD. So here we'll take AD upon CD is equal to, again I want AD in my final result. So I'll take, in this side I'll take BD upon, here I'll take AD. So solving this, we'll get AD square is equal to BD into CD. Hence, we have proved our final results. Now take the third example. In triangle ABC, AD is perpendicular to BC such that AD square is equal to BD into CD. We have to prove that triangle ABC is right angled at A. So this is just the converse of the question number 2, which we have seen in the previous video. This is the converse of that. So let's make the diagram for this question. We have the triangle ABC and AD is perpendicular to BC such that this two things are given. This is perpendicular and AD square is equal to BD into CD. What we have to prove? That angle A is equal to 90 degree. Angle A is equal to 90 degree. How will prove? If somehow we can prove that BC square is equal to AB square plus AC square, then we can say that the triangle ABC is right angle at A. It is the converse of Pythagoras theorem. Pythagoras theorem. So if we can prove this, then it's implied that the triangle is right angle triangle. So I'm going to prove this result. So let's try to do this. What we are given is AD is perpendicular to BC. So apply Pythagoras theorem in triangle ADB. Applying Pythagoras theorem, we have AB square is equal to AD square plus BD square. And again in triangle ADC, we have AC square is equal to AD square plus DC square. Okay, so AB we have, or also AC. So let's add these two equation 1 and equation 2. We're going to add this. So in the left hand side we'll have AB square plus AC square is equal to AD square plus BD square plus again AD square plus DC square. So AB square, BC square, this we have got here also. And in the right hand side we have 2AD square plus BD square plus DC square. Sorry, this is DC square. Yeah. So again, one thing which we are given is AD square is equal to BD into CD. So we are going to substitute this. So AD was equal to BD into CD. So this is 2 times BD into CD whole square plus BD square plus CD square. So from here we can say this is 2BD square plus 2 times CD square plus BD square plus CD square. Yeah. Oh, I'm sorry. It should not be square, because substituting AD square as BD into CD, here I have written this should not be square, this should not be square. So I have to erase all this. Yeah. So substituting AD square as BD into CD, which was given in our question. AD square is equal to BD into CD. So from here, what we can say, this whole term is equal to BD plus CD whole square. Yeah, if we'll open this, we'll get this only. BD square plus CD square plus 2 times BD into CD. So we'll write this. And again BD plus CD. If you look in our diagram, BD plus CD is BC. So what we're going to write here, BC whole square. And on left side we have AB square plus AC square. Hence proved.